Imagine this, a single web request, and suddenly an attacker owns your entire cloud account. That's not Hollywood. That's what happens when SSRF, metadata exposure, and IAM key abuse are chained together. Welcome to episode 2 of our Vulnerability Chaining Masterclass, where we break down one of the most devastating cloud attack flows in modern history. Before we dive in, a quick but important disclaimer. This content is for educational purposes only. All demonstrations are recreated in a controlled lab environment using intentionally vulnerable applications and fake credentials. Do not attempt these techniques on any system you do not own or do not have explicit written permission to test. Stay ethical, stay safe. Here's our journey today. We'll start with SSRF, understand the hidden metadata service, see how IAM keys can be stolen and abused, then connect it all into one devastating chain. We'll also revisit real-world breaches like Capital One and a 2025 campaign uncovered by F5 Labs, but strictly from publicly available reports. Finally, we'll look at defenses that break the chain before it causes real harm. Cloud breaches today don't usually start with a genius zero-day. They start with small cracks, a misconfigured app, an over-permissioned IAM role, a metadata endpoint that shockingly doesn't even require authentication. String those together, and suddenly you're looking at a complete account takeover. That's why 84% of cloud breaches involve privilege escalation. The real danger isn't one bug, it's the chain. So what exactly is SSRF? Server-side request forgery. Think of it like this. Imagine you convince a friend to send a message on your behalf to someone they trust, but you sneak in a different address. That's SSRF. The vulnerable app becomes your middleman, blindly fetching whatever URL you give it. If you point that request at a hidden internal service, well, now you've crossed the firewall without ever touching it. Let's walk through the flow. Step 1. The attacker finds a field that accepts a URL. Step 2. The app dutifully fetches that URL, no questions asked. Step 3. Instead of a safe external site, the request goes to the cloud's metadata service. Step 4. Boom. Out comes sensitive credentials like IAM keys. One unvalidated URL turns into a golden ticket for cloud access. Here's the side-by-side. On the left, a normal user asks for data from a trusted API. The app checks it and returns the info safely. On the right, the attacker swaps the URL to 169.254.169.254, that secret internal IT every cloud instance uses. Since the app doesn't validate, it happily fetches IAM credentials instead. That's the difference between safe and catastrophic. Just one missing validation. Attackers, of course, don't stop at the basics. If you block the raw IP, they'll URL encode it as %31, %36, %39 and slip right past filters. If you block domains, they'll use DNS rebinding, tricking the system by resolving a safe domain at first, then flipping it to the metadata service mid-connection. It's like a magician's sleight of hand. You think you're safe, but the trick is already done. Now, why is metadata such a big deal? Think of the metadata service as your cloud instance's diary. It contains who it is, where it's running, and most dangerously, its IAM role credentials. With IMDS verse 1, there's no lock on that diary. Anyone who can reach it can read it. IMDS verse 2 finally added a lock, but many systems still run verse 1. And that's why SSRF plus metadata is a dream combo for attackers. Here's how the attacker plays it step by step. First, they test SSRF with their own domain just to confirm. Next, they query the metadata endpoint. Then, they ask for the IAM role name. Finally, they pull the full credential set: access key, secret key, and session token. With those three, they don't just peek inside, they become that cloud instance. Stealing IAM credentials is like stealing someone's passport and credit cards together. It's not just identification, it's authority. With IAM keys, attackers can roam the entire AWS account, list S3 buckets, spin up servers, or tamper with IAM roles. In cloud terms, this is game over. And here's where it gets even scarier. 2 killer moves. First, policy attachment. With one command, the attacker slaps the administrator access policy onto themselves. Instant God mode. Second, Lambda injection. By updating the code of a Lambda function, they plant a permanent backdoor that executes every time the function runs. Both are stealthy, powerful, and devastating when changed from SSRF. Let's connect the dots. Step 1. SSRF lets the attacker forge requests. Step 2. Metadata spills the IAM keys. Step 3. IAM keys are abused to escalate privileges and full account takeover. Research shows that chaining like this succeeds over 90% of the time, with more than 5 times the impact of isolated bugs. This is why defenders must think in chains, because attackers already do. And if you think this is theoretical, think again. Real-world breaches have used this exact chain. Let's unpack 2 cases. Capital One, one of the largest data breaches in financial history, and a 2025 F5 Labs report that showed this attack is still alive and well in the wild. The Capital One breach in 2019 followed this playbook to the letter. A misconfigured firewall let SSRF through. IMDS v1 happily gave up IAM credentials. Those credentials had excessive permissions to S3. The attacker copied 106 million records, including social security numbers and bank accounts. The cost? Nearly $200 million in fines and settlements. And all from a single SSRF exploit chained with weak IAM controls. Disclaimer. All details here are drawn from public reporting. This reconstruction is for education only, not exploitation. Fast forward to 2025 and nothing has changed. F5 Labs tracked the global campaign hitting EC2 instances across multiple regions. Attackers rotated parameters like URI and target until they got through, then pulled IAM credentials straight from IMDS v1. Same exploit, new victims. And the scary part, the fix, switching to IMDS v2, has existed for years. It wasn't patched because of operational inertia, and attackers love inertia. Disclaimer. These details are based on public reporting only and shown here purely for educational purposes. So how do we stop this? First, enforce IMDS v2 everywhere and kill off v1. Second, validate inputs and block requests to metadata IPs. Third, apply least privilege to IAM roles so stolen keys don't mean total compromise. Fourth, deploy VAPs and egress controls to stop SSRF in the first place. And finally, monitor relentlessly with CloudTrail and GuardDuty. Remember, break one link in the chain and the attack falls apart. Subscribe now so you don't miss it. Because if episode 2 taught us one thing, it's this. Attackers think in chains, and so should we. And always remember, the labs here are safe, but in the real world, only test on systems you are authorized to. In episode 3, we'll look at an even more complex chain. Web cache poisoning, API Bola, and cloud supply chain attacks. Thanks for watching. Stay secure.